If you want to convert this to poked form, we know in poked form we have a starting amount, P naught, which we already can see is 300, times e to the k times t. So the key here is both of these forms are going to have t as the variable, right? T, 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 t. But we need to figure out what the k value needs to be so that when we have e to the k, it gives us the same situation that's happening here. So what's happening here is we're dropping to 75% every 12 years. So dropping to 75% of what we were, or losing 25% every 12 years. So if we plug in 12, it's 0.75 to the 12 divided by 12 is 1. If we plug in 24, it's 0.75 to the 24 divided by 12, which is 2, meaning we're going to take 75% twice, 75% of what we had. So if we use a base of e, then we can say e to the k times 12 equals 0.75, right? Because we're saying whatever our k value is, if we plug in 12 for our t value, we should have 75% of what we started with. So if we convert this to a logarithm, natural log 0.75 equals k times 12. And then if we divide by 12, we should get our k value. So natural log 0.75 divided by 12 is negative 0.023973. So what you should do on the test here is you should write out as many decimals as you can. Negative 0.0239730506, right? It's going to maybe keep going. But write out all those decimals. You can always just store this in your calculator, and then you could do something like this where you just like draw a line connecting these, right? So now we're in poked form. If we do 300 times e to the, and this is our k value times t, that's going to cause us to lose 25% every 12 years. These two functions are exactly the same. And we did it by saying, well, we know that we're going to be 75% every 12 years, so we can say e to the k times 12 equals 0.75 and just solve for our k value. And we have it in this form now because it's easier to take a derivative of this function, and it's just helping us understand e and how it works.